In this video we're going to talk about configuring a secure sockets layer bridge connection on a Mosquitto broker. Now, a bridge lets you connect two MQTT brokers together. They're generally used for sharing messages between systems, and a common usage is for edge networks where you connect the external brokers to a central broker. And there's a diagram here that illustrates that. So we have a local broker here with local clients, and it connects across the internet or across the network to a remote broker. Now, in an earlier video I showed you how to set up the bridge connection. There's a link in the description below, and we looked at topics and bridging certain topics. We're not going to look at that in this video. What we're going to look at is actually securing this connection between these two brokers. So we're going to set up secure sockets layer to operate between these two brokers. Now, Mosquitto provides two methods of using secure sockets layer encryption on a bridge connection, and it's using certificates. And we covered certificates in an earlier video, and again there'll be a link in the description below. But that was configuring secure sockets layer between a client and a broker. And the other method we're going to look at is pre-shared key encryption. Now, you can't do that, you certainly can't do that on the Python client between the broker. The Python client doesn't support pre-shared key encryption, but you can do that between two brokers, and we're going to look at that as well. So how does it work? Well, when you configure the Mosquitto broker as a bridge, it becomes an MQTT client, and it subscribes and publishes to topics on the other broker and itself, depending on the entries in the conf file. The entries meaning what topics you've configured to bridge. Now, with an SSL connection, the server is the one that requires a secure connection, and the client must comply. When we look at our connection, what we've got here is broker 1, and this is acting as the bridge. So this is effectively going to be a client to broker 2. Now, broker 2 is acting as the server. So as far as secure sockets layer is concerned, this is where we configure the secure sockets requirement on broker 2. So broker 2 basically tells broker 1 that I'm going to use secure sockets layer, and broker 1 has to comply or the connection gets rejected. So here broker 1 is acting as the client, and broker 2 is effectively acting as the server. Now, as regards the bridge topics, then they're configured on broker 1 because broker 1 is the bridge. Here's another little diagram here, and generally broker 1 is going to have its own local clients, and these will be connecting to broker 1 unencrypted using the standard 1883 port, and broker 2's probably got its own local clients, and again they'll be connected locally using the standard 1883 port. And it's this connection here that we're going to secure. So what do we need to configure? Well, we need to configure the standard bridge, which is the address and port of the remote broker or brokers if we're having more than one bridge connection, and we're going to cover that as well later on. A client name, what topics a broker will publish and which topics it will subscribe to, the topic mapping, and topic remapping if needed. And then we need to configure either the secure sockets layer certificate, or we're going to configure the PSK file if using PSK. You can't use both, so it's one or the other, so it's either certificates or PSK. Broker 2, remember broker 2 is acting as our server, so we basically tell it to listen on port 883, which is the standard secure sockets layer port. We're using MQTT as a protocol, and we need a CA file, a key file, and a cert file, and these I covered in the other video. There's a link in the description below on configuring secure sockets layer. The little note there says generally there's local clients using port 1883, so you should have an extra listener up here listening on 1883 for those local clients. It's not shown in the config file. This is just a config for secure sockets layer. Now, broker 2 is not a bridge, so we don't see anything here for the bridge connection. That's all done on broker 1. So if we go over to broker 1, so here's the bridge configuration on broker 1. The name of the bridge, the address, I'm using workstation 4 because that's the way I configure the certificate on the server, and the path to the CA certificate file, and this CA certificate file is the same one that's on the server. And these are the topics that I'm bridging. Now, I'm not really interested in those, but I do recommend that when you're setting it up, you bridge all topics. You don't try to combine things, so you set it up to get secure sockets layer work. Then if you want to restrict the topics, then you do that later on. The same as if you want to use password protection as well, you do that later on. You don't try and do it all in one go. And again, there's a little note there that says the local clients will probably be using 1883, so we'll need an entry in the file for that as well, and it's not shown there. Okay, testing it. Well, there's no real easy way of testing it except to cause an error. So what you do basically, or what I do, is I just give it an incorrect CA path, or I give it an incorrect CA file, and you should see a secure sockets error appearing on there. Let's say when you actually, once it's configured and you start sending messages between those bridges, you can't tell unless you actually go and have a look at the data flow using something like Wireshark that is actually encrypted. Have a look now at using pre-shared key encryption. Now, a pre-shared key is a shared secret which was previously shared between the two parties using some secure channel before it needs to be used. That's the wiki definition. It's basically the same thing as you use on Wi-Fi networks. So you connect to a new Wi-Fi network and it asks you to type in the password for that network, and that's basically what we're doing here. We have a password, and in Mosquitto it's actually restricted to hexadecimal numbers, so we have to use 0 to 9 A B C D E F for the password, or should I actually say it's a pass key. And we have the same pass key on both the broker 1 and broker 2, and they have to know, or they have to use the same key to communicate, and that key is used to secure the connection. Now, I actually prefer this method because it doesn't rely on certificates and it's actually very easy to configure. Now, you can generate the key using key generators, which are basically random number generators, or you can just simply make one up. Now, I just made one up, and you can do the same. In a real world deployment, you'd have some security policy regarding the strength of those keys, but generally the longer the length, the more secure they are. And there's a little note saying it's the PSK encryption uses secure sockets layer just like certificate based encryption, so it's just as secure. What isn't as secure is the key distribution. We're going to use the same setup as before. Broker 1 is going to be configured as the bridge, and broker 2 is going to be the normal broker, and broker 2 is the one that's basically going to request that broker 1 uses PSK encryption. We're going to look at the various entries in the files in a second, so I won't go into that. So here's the bridge configuration. This is broker 1. Now we've got the connection and the bridge identity. Now the bridge identity, this bit here is important, bridge 1. Now I can choose any name I want, I just called it bridge 1. And the PSK, which is basically a random number that I made up, that entry there, bridge 1, and that entry there has to match the entry in the PSK file configured on the remote broker, which we're going to look at in a second. Now I've just commented out the entry that we had there earlier for the certificate, and there's the topics that I'm going to bridge. I'm going to bridge all. So on broker 2, the important entries are the PSK hint and the PSK file itself, and we have to create the PSK file, and I'll show you that in a second. Now apparently the PSK hint is the important one. It tells the broker to actually use pre-shared key encryption. You can put any value you want in there and it doesn't seem to matter. Now from what I read, it does matter on some systems, but on Mosquitto it doesn't seem to matter, and we'll see the entry in a second. And you can only have one PSK file entry, so you can't use two PSK files. So here's a configuration. There's the PSK hint, and I just called it my test bridge. You could have called it anything you want there, so you can put any text you want there. And here's the path to the PSK file, and again I've commented out the entries for the certificates because we can't use both together. Now the important bit is the PSK file, and this is what it looks like. Now bridge 1, if you remember back, the bridge identity was bridge 1, and this is the number I made up there. There's actually 2 entries in this PSK file, but there could be more, or it could just be a single one, just bridge 1. Now bridge 2 entry I'm going to use later on when we configure multiple bridges, so this is actually going to be used. But say you could see lots of entries in here, and these are numbers, and you can either generate them, like I said, using a random number generator online, or you can just make them up. Okay, let's look at multiple bridge configurations, and we're going to examine 2 scenarios, and the diagram below actually depicts a connection or typical what I call branch office central server type configuration, where we've got a branch office here, broker 1 with its local clients, and we've got a broker 3 with its local clients, and they both connect to the central broker, which is broker 2. Now broker 2 is basically our server. This connection between the two, or the brokers, is going to use secure sockets layer. The local part over here will just be standard port 1883 unencrypted generally, so we won't use encryption locally, we'll only use it across the internet. And this, I think, is going to be one of the most common scenarios you'll be seeing, that and the other one which we're going to have a look at in a second. Now broker 2 doesn't need any configuration change, support multiple bridge connections, whether we're using certificates or PSK. If we're using PSK, which is what I'm actually going to illustrate, then we may need to add another entry for the other broker, but I already did that previously, so as I showed you with the PSK file, there are actually 2 entries there. And the configuration on broker 1, which is bridge 1, is that what I showed you previously, and it doesn't need any changes. So the only thing we need to do is put an entry into bridge 2, which is on broker 3, and here connection name, the address is the same one as we were using before. Bridge identity, now this is the important bit, and if you remember back to the PSK file, there was an entry in there for bridge 2, and the bridge PSK, which should match the entry to the other one, which is, it's the same one, just ends in a 2. And if I go back and show you that quickly, you can see it here, bridge 2, and there's the entry there. Now the second scenario, this time we've got effectively a branch office with this broker here having 2 connections, one to broker 2 and one to broker 3 across the internet. We're going to secure this here. Now this is again be a typical scenario where we need redundancy, so if this connection, the main connection, fails, we need to move over to another connection so we can always communicate with a central broker. So this broker here, broker 1, is going to support multiple bridge connections. Now we'd usually use the same port for each bridge, so we're going to use a single listener on 883, so both of these connections here are going to be using port 8883. Each bridge connection starts with the connection name, and we're going to call them bridge 01 and bridge 02. And here's the configuration. We're listening on 883. This is the entry for the local clients. Remember I said the local clients would be using unencrypted connections. Here's the bridge identity, and here's the number. And I say I've commented out the certificates. We're not using certificates, we're using PSK. And for the second bridge entry, again it's called bridge 2, and there's the number. And the PSK file will be sitting on the broker, which will be sitting on broker 2 and broker 3. And this is what it looks like, and it's basically the same as what we saw earlier on. Now testing, as I said before, it's not easy to test it, because unless you actually go in there with a network monitor. The way I do it is basically cause an error, like I said before. This time I've caused an error on the bridge 2, and all I did was change this number, and I changed it to a 3 or a 4, so it's invalid. And as soon as you start the connection, then you come up with an error, secure sockets error message. So that's the way I tested it, basically to confirm that it was actually using secure sockets layer. But I say, other than that, you have to go onto the network and with a monitor like Wireshark to monitor the traffic to convince yourself that it is using secure sockets layer. Okay, that brings to the end of the video. If you go onto the website, there's a tutorial, written tutorial, basically cover what I've covered in the video, but you'll find links to other articles there that you may find useful. And in the description below, you'll also find links to the previous videos and also to the written articles or tutorials on the website. Now, if you have any comments on the video, then you can leave them in the form below. If you like the video, then you can like it using the like buttons below. And if you want to know when I publish new videos, you can always subscribe to the channel. I do publish an occasional newsletter, and if you go over to the website, you can subscribe to that as well. So that's the end of the video. Until next time, goodbye.